Hey there, welcome to a video discussing section 5.6, which is about a few theorems on polynomial functions. So I'm going to try to keep this video somewhat short, mainly because it's 1:46 p.m. on Tuesday and I am teaching B period in about 14 minutes. So let's see how this goes. So in the box, you see two theorems, remainder theorem and factor theorem. So the remainder theorem is stating that if you divide a polynomial f of x by x minus k, then the remainder is the same thing as if you plugged in k into the function. And I'll show you how that works in a sec. Whereas the factor theorem is kind of the same thing, that if you do have x minus k as a factor of f of x, then if you plug k into x into the function itself, you would get 0, meaning that the remainder is also 0. We actually kind of talked about that in the previous section. So without further ado, let's look at example 1. So they say use synthetic division of value f of 4. Well, here's the thing. F of 4, if I were to work it out, pretty straightforward, you know? Just plug in 4 in for x. Use a little arithmetic to work it out. 64 minus 96 plus 20 plus 12 plus 32. So I think we get 0. Yeah. Now, if you decide to use synthetic division, or we call synthetic substitution, that's actually probably a better way, because we're not actually doing a division problem here. 1, -6, 5, and 12. Actually, let me space out that 12 a little bit better. Put 4, drop the 1, 4, -2, -8, -3, -12, 0. So notice how our remainder here is 0 and it's the same thing as that. So that's basically using the remainder theorem, that if k is 4, and if I did f of x divided by x minus 4, so I guess I am doing a division problem here, then a remainder, which is 0, is the same thing as f of 4. So the remainder, and if you plug this number into the function, they're going to be the same thing. That's what remainder theorem is all about. So make sure you've got that down. Then for b, if I factor completely, well, fortunately, I already know that f of 4 is 0. It means that x minus 4 is a factor of f of x due to the factor theorem. Because f of x is the same function that we were working on just a minute ago. So what I could do then is take those numbers, and that will be the coefficient of my quotient, as we talked about in the previous section. And fortunately, I can factor this further: x minus 3, x plus 1, x is 3, and -1. So those are my other two zeros. But actually, he wants to factor it completely, so it's just x minus 4, x minus 3, and x plus 1. That's what f of x is. Okay, let's keep moving. So again, just some terminology. 0 is whatever makes a function 0. So if k is 0, the polynomial, then f of k is 0. Very important. X minus k is a factor. That's if this happens. K is a solution, of course, when we set the equation equal to 0. And k is also an x-intercept. That's how we can think about these graphically. So for example, if I wanted to graph the polynomial in example 1, I know my x-intercepts are -1, 3, and 4. And the end behavior is down then up. And y-intercept is pretty high, it's at 12. I guess something like that. So you can see how factoring could help us with graphing. Okay, the rational zero theorem. So yet again, we have another theorem. So this is telling us that as long as your function has integer coefficient, means like no nasty fraction of the decimals, then every rational zero, meaning a ratio of two integers. Remember, rational numbers, examples are like 0.5, 0.3 repeating, 1/2, 1/3, Even numbers like 2 or -1, those are all rational numbers. We'll have the following form: P over Q. P represents the factors of the constant. Q represents the factors of the leading coefficient. Now I do have to state that these will give us possible zeros. There's a likelihood that these would not be zeros in actuality. So that's why we have to use the word possible. So when we ask those possible rational zeros, if you follow this formula here, or this theorem, P represents all the factors of a constant, or the factors of 20. 1, 2, 4, 5, 10, and 20. Where all the factors of my leading coefficient is just 1, so just 1. And I got to put plus or minus because obviously 20 can be divided by negative numbers like -2, -4, -5, -1, -10, -20. So if I divide all these by plus or minus 1, it just stays the same. Anything divided by 1 itself. And if you see, there's a lot of possibilities. In fact, if you count it, there are 12 possible rational zeros. So any of those 12 could be a solution to that equation if I set the equation equal to 0. Here's the deal, though. None of them may work. So there's a possibility that none of them would be good for us. So when you're asked to test them, what you're going to wind up doing is actually using synthetic division. And there's a little bit of trial and error involved. Personally, I hate trial and error, and I'm not going to force you to do it. I'm going to do it here in the video just for the sake of doing it, but it's kind of a pain. You can see how that doesn't work because our remainder is not 0. So if I try it again, because remember, you want the remainder to be 0 if you want it to be a 0 of the function or to be a factor. If I do -1, let's pray that works. So what I would do is I would probably tell you what one of the zeros are. At least you know what to try, or I would let you use a graphing calculator and find one of them. I think we're going to have a winner. Yep, bingo, we got a winner. So that's x squared minus 9x plus 20. So when you're asked to find all the real zeros, I could just factor that. X minus 4, x minus 5, x is 4 or 5. So example 3 is kind of more the same thing. I do see the bell's going to ring in a few minutes, so I'm going to do this kind of quickly. P over Q. These are all the factors of 16. So of course, these are all the factors of 4. So there's a lot of possibilities. Obviously, all the numerators that you see here are possibilities we divide by plus or minus 1. Or plus or minus half. Or plus or minus 1/4. You could also do 4 over 2 or 4 over 4, but they'll be repeating what we already have. So is x minus 1 a factor? Let's find out. Now, if you don't see a term, like notice there's no x squared term, you got to make sure that you put a placeholder, so don't skip the x squared term. Drop the 4, there's the bell. So I'll wrap this up. So yes, it is, because you get 0 over here. And then all you need to do is set this equal to 0, factor out of 4, and because there's a hint that I use club form, that's what we got to do. X equals -1 plus or minus b squared minus 4ac all over 2a. Fortunately, that will be real. You get root 17 over 2, and there you go. Those are your other zeros. If you do in the calculator, you get these nasty decimals, so this is what we call an exact answer. Okay, that completes the video. And we'll definitely have a discussion about this on Friday. I think I see all students on Friday. Yes. Okay, we're all set.